Welcome back. In this episode, I'm going to show you how we can calculate our restitution coefficient in a different way. I'm also gonna add back we are gonna add the boundaries, and I'm gonna add back the gravity force. All right, first, let's jump to the collision manifold file, and here we're gonna calculate our restitution, the E variable. Okay, and one way to do it is we're just using the maximum or the minimum bounciness of the material. This is, I think it's a way Unity does it, the Unity engine. Yeah, and we can implement it like this. This dot rigid a dot material. Oops, what's this? Material dot bounce, and we just take the minimum from one of these. Okay, this is one way to do it, and the other way is to say the restitution, the coefficient is 2 times the bounciness of the first rigid body times the bounciness of the other rigid body divided by the summation of both, like this. There you go. Yeah, like this. This is one way to do it, and the other way. Yeah, if we jump back to the browser, it should still working. There we go. It still works. Awesome. Yeah, and now I'm gonna jump back to the simulation, and we are going to add a new method, and this method will be responsible to create our boundary. So I'm gonna call it create boundary, and here I'm gonna say this dot rigid bodies dot push. Here I'm gonna say a lot, 4 different rigid bodies I'm gonna push with a mass of 0, so they're kinematic, they won't move, they're just there to solve our boundaries, that nobody will jump out of our canvas. Okay, let's add that. I will just copy this one and paste it in here and change the coordinates. This will be this dot world size, and I hope I already declared world size somewhere. Say y value of 100. Oh, 1 second. Oh yeah, world size dot x divided by 2. With minus 50, so it's not seen in our canvas. Then the width will be this dot world size dot x with a height of 100. I think it was height. 1 second. Yeah, it was height. All right, and a mass of 10. A mass of 0. Okay. And I'm also gonna call this right there. This dot create boundary. Okay, did I create the world size somewhere? No. All right. Then I'm gonna pass it into the constructor, and I'm gonna say this dot world size is equal to world size. All right. And of course I need to change in the main HTML that the world size is passed into this. Okay. This will be, yeah, right there. Where's the simulation? There we go. And this is just also a vector 2. And this will be canvas width in this case, and canvas dot height. All right, let's see if it's still working. Okay, it works. And you can see our boundary in the top. Later we're gonna move it a little bit more so we can't see it anymore. But this is working, and let's see if the collision does also work right. Yeah, cool, it works. Awesome. Then let's jump back to the code again. In the simulation class. Right. I'm gonna add the other two, so I'm gonna just copy this one again. This time we need to change this parameter. This will be world size dot y plus 50. Yeah. And if I refresh my browser, then oh, okay, that's not true. Of course, it's because of the rotation. I'm gonna remove the rotation right here. I'm gonna remove this one. Okay, and then refresh again, and there we go. We have our boundary again. And if I move my rectangle again, oh yeah, and I need to change the objects, the indices in the movement in the on keyboard press method too, but I'm going to change that at the end. All right, then let's add the other two boundaries to this one. I'm gonna again just copy one and change the values. This one will be, the coordinates for the third one will be -50. And here I'm gonna say 100. And the height will be this dot world size dot y. Oh no. This will be 100, and the width will be no, I mean the height will be world size dot y. Okay. Now I'm copying this one again, and this time here I'm gonna change this one to this dot world size dot x plus 100. Then here this dot world size dot y divided by 2. This will be 100, and this will be world size dot y. Okay. Then let's jump back to the browser, and oh, I forgot it again. I changed, I added these two here again. Just pause the video and type it. Yeah, I think that's the best. Okay. Then let's jump back to the browser. And there we go, you have our boundaries now. Awesome. This one is a bit wrong, so I guess I made a mistake. Is it the fourth one? I'm not quite sure. This one is correct, and the other one. Okay, yeah. I have to change this 100 to this dot world size dot y divided by 2. Okay. And now I'm gonna change the on keyboard press method too. Okay, I'm gonna set here a new variable called length, and this will be this dot rigid bodies dot length. And now I have to do the things all again. Maybe the alt trick is working again. No, it's not working. Damn it. Ah, damn it. Alright. Maybe now? No, also not working. Ah, okay. Maybe. Ah, okay, now it's working. Cool. I'm gonna say length -2. And the same thing I'm gonna do with this one. Here I'm gonna say length -1. Alright. Now let's jump back to the browser, and now everything should work as intended. I hope at least. Okay, the circle is moving. Okay, awesome, that's working. Yeah. Okay, now how's this game called? Breakout? The one with the bricks? Right, it looks good. Cool. Only my left, I'm not quite sure why this isn't working. Ah, yeah, the big rectangle doesn't move. That's why it's not doing anything. I'm gonna set this one to 2 and refresh. And now I can also move the other one. Alright. So just play a bit around with the weights, with the masses, and then, yeah, everything should work. Cool. I think our small rectangle is stuck inside the boundary here. So I'm gonna move this one a little bit outside. I think this is this one. Just gonna say 200. Refresh, there we go. Okay, and then hit force. Cool. Really nice. Okay, this is now working. Now I'm gonna add the gravity again. So gravity, like we did previously, I'm gonna add this one right under the rigid body array. And I'm gonna say gravity is equal to a new vector 2. And here it's just gonna have a value of 100. Not that much. But of course you can change that if you like. And then we need, of course, we need to apply the gravity too. And this will be in our update method right here. I'm gonna say let gravitational force is equal to sub. No, I want to have a scale. Is equal to this dot. 1 second though. Actually, I can just add it to the rigid bodies. So this dot rigid bodies y dot add force, and oh yeah, of course I confused that a little bit. The gravity I declared is a acceleration and not a force, of course. So I'm gonna redo that like this. And here I need to calculate from the from the gravitational force, well, that's a acceleration, and I need to do the other step. Convert the acceleration to a gravitational force. Yeah, and we can do that by using this formula. F is equals to mass times A, where A is the acceleration and A is our gravity. And we need to calculate this force to add it to a body. So we can just say scale, just make sure that you use the right one. Yeah, this dot gravity by this dot rigid bodies dot mass. All right, and then we have the gravitational force. In this case, this is like this now, okay? And this is a acceleration, not a force. Good, and then we can add the force to a rigid body. This dot rigid bodies, add force, and then we can say gravitational force. All right, I think that's it. Yep. Then let's jump back to the browser and see what's happening. Our objects falling to the bottom. Cool. And now you will see the same effect we had previously, that the objects will stuck if some of them will finally calm down. I'm gonna change the velocity damping a little bit higher. You don't need to do that, just to see it faster. Okay. And then I think you can already see that the objects sliding into each other, like the circle. Though the boundary is not moving anywhere, it's just the other shapes which are sliding in that. And we are gonna tackle this problem in the next episode. Okay. Then see you in the next one, and have a nice day. Bye bye.